Now let's explore the fourth and final pattern, interpretation. This represents the ultimate in flexibility. It treats your DSL programs as data structures that can be interpreted in multiple ways. This separation of definition from execution opens up possibilities that aren't available with the other patterns. Now, most programming works like this: you write code and it executes immediately. The definition and execution are tightly coupled. But what if you could separate them? Now, instead of immediate execution, you build a data structure. Notice what's different here. Instead of having a process method that does work, these are just data structures, records that hold information. The read step just holds a source file name. The filter step holds a description and a Java expression as strings. They don't do anything, they just describe what should be done. A pipeline definition is just a list of these step descriptions. It's pure data, no behavior whatsoever. Now, your pipeline becomes a data structure that describes what you want to do rather than code that does it. The user pipeline here is just data. It describes a pipeline but doesn't execute it. The power comes from being able to interpret this data structure in different ways. Now, you could have a standard execution interpreter. The pipeline executor here knows how to take a pipeline definition and actually run it. In the execute method, we iterate through each step description and call execute step to perform the actual work. The execute step method uses pattern matching to handle each type of step. For a read step, it reads from the file. For a filter step, it compiles the Java expression string into an actual predicate and applies it to that. For the transform step, it compiles the expression into a transformer function. For a write step, it writes the data to the destination. Or you could have a SQL generation interpreter. The SQL generator takes the exact same pipeline definition and converts it to SQL instead of executing it directly. For a read step, it converts the file name to a table name and starts a select statement. For the filter step, it converts the Java expression to an SQL where clause. For a transform step, it converts the transformation to an SQL expression. This is powerful because you can run the same logical pipeline either in Java or in a database. Let's look at another one, an analysis interpreter. The pipeline analyzer examines the pipeline definition without executing it and provides insights. It can calculate complexity scores, identify file dependencies, detect potential performance bottlenecks, or validate that the pipeline is well formed. Now, the same pipeline definitions can be used in different ways. You can either execute directly on your data, you can convert it to SQL and run it in a database, you can analyze it for complexity and dependencies, or document it by generating human readable descriptions. You could even optimize it by reordering steps or validate it before execution to catch errors early. The interpretation pattern works because it separates three concerns that are usually tangled together: what you want to accomplish, which is the definition, how you accomplish it, which is the interpreter, and actually doing it, which is running the interpreter. This separation enables incredible flexibility. You can change how something executes without changing what it does.